Thanks for the opportunity to speak today. We'll go ahead and jump into the agenda, and then we'll dive right in. So today we're going to talk about the grading of the installation of HVAC systems and the new standard 310 that has been released recently. I'll give a brief introduction of EI and myself. We'll talk about some of the history of HVAC commissioning, provide an overview of standard 310 since we details of standard 310 practice are available. I did a seminar with Dean Gamble from EPA's InterStar program at the EBA conference recently, so we'd be happy to log on and have access to that if you'd like to get details. Today we're just going to do an overview of the standard, provide a status of where it is and when we can begin using it. And then we're going to talk a little bit about why standard 310 is important, why it's necessary to our industry, and the opportunity to HERS raters. So just a brief bit about EI. EI is focused on engineering, building performance, and construction quality services to the building community. We operate in 8 states with a little over 260 employees and provide design services across pretty much coast to coast, with an emphasis on residential, mixed use, and multifamily construction. If we can go to the next slide if possible. There we go. So a little bit of the history of HVAC commissioning. Installation defects in HVAC are commonplace. This has been known for a long time. There's a variety of studies that have been done in the published literature going back 25 plus years, indicating that HVAC is challenged. This is a listing of some of the technical articles focusing on how improper airflow affects HVAC design. If we go to the next slide, there's another set of articles here that have analyzed the impact of improper refrigerant charge. So there's a lot of ways to get HVAC installations wrong. Those can have a significant impact on the overall performance of the system from an energy perspective. And if we go to the next slide, you can see that not only there have been a number of studies done, but there have been studies summarizing all the studies that have been done. So HVAC issues and their impact on energy performance of homes is well known. It's well documented, and we have been working on trying to get a standard in place for some time. If you go to the next slide, if a number of those issues that those studies that you noticed were funded and performed in California. California Title 24 has had a focus on HVAC commissioning for a number of years. And it really was the blueprint for standard 310 that we started with. There's some changes, but it was really the starting point for this because this concept was introduced back in Title 24 in 2006. It was pretty significantly enhanced in 2013, and then over the years it has become a mandatory test for a home to meet code in California. And as many people know, California doesn't follow the international codes. It has its own set of codes that are similar but not the same as the IECC. So this has given us a lot of data. There have been tens of thousands of homes that have been had HVAC commissioning performed on them as a requirement to meet code. And so that has given us a lot of data. It is very similar to standard 310, as we'll get into it a little bit. The main difference is that the refrigerant charge testing that's done in California is actually using gauges and doing what's called invasive testing, because you're actually measuring pressures and temperatures of the HVAC system, where standard 310 is a non-invasive method. We'll get into that in just a little bit. The experience that we've had in California is that the number of issues has been considerably less than we would have expected. Some of the challenges that we addressed with standard 310 of what's the interaction between the HVAC companies and the raters going to be, is this going to slow things down? Is it going to be expensive? The net result is in California that we have greater relationships, more closely tied relationships between the HVAC contractor and the rater, and that the number of comfort issues and the energy performance of homes has significantly improved. So it's been a positive thing for the state of California. Now with Standard 310, it'll be it's an optional method of improving performance for homes throughout the country. Myself, I've been before EI, I was an HVAC contractor, both in new construction for a number of years and in service replacement. The experience we had during the housing boom was that we had significant HVAC service and warranty issues and energy performance issues. We had a CAD team. We had an entire air balance department of 12 staff members. Our warranty service team had 40 call center agents. We had a huge warranty issue with homes that were built during the boom times in the early 2000s. During the downturn, those issues really brought to light all the challenges of service issues when your volume drops off. So we made a transition and really converted our CAD team, which was just really drawing up plans that were field designed, into a true engineering department, using modern tools, following manual JS&D to ensure that we had proper designs that met the actual performance of the homes. We built a detailed startup and commissioning department that focused on doing lot-specific detailed commissioning, including lot-specific air balances. We were able to dramatically reduce the number of customer service calls. For one builder, we measured the number of comfort complaints that were related to HVAC, and we measured them the year before the transition, skipped the year of transition, measured them again the year after transition, and we were able to eliminate 90% of the HVAC comfort calls by doing it this way. So we converted from a huge warranty service department to a scheduling and call redirection department, including the last year that I owned the HVAC company. Our number one customer service call from homeowners had to do with them not understanding how to properly use the system. So we actually pulled someone from the field to just direct those calls so that homeowners would understand that you can't run your thermostat up to 90 degrees in the middle of the day and expect it to reach 75 in 10 minutes when you get home. So all of those kinds of issues were addressed, but the huge positive impact on the company from designing and commissioning systems correctly, it was something that was very obvious to us. So a little bit about Standard 310. This has been in the works for some time. The working group was formed back in 2016. Bit of a sausage making process. It's kind of ugly along the way, but hopefully the end result, is a good thing. Dean Gamble headed up this group from the Energy Star for New Homes program at the EPA. He is a master cat herder. It's amazing the ability to pull together very, very opinionated people that are raters, HVAC contractors, building science gurus, experts from various government agencies, and trying to get this group together to say, okay, how should we do this, and what is the impact that HVAC design and commissioning has on energy performance. And ultimately, that group was able to work with input from the public to come up with what is now an ANSI Standard 310 supported by ACA and ResNet. So what is Standard 310? So this is a quick snapshot of the process you go through to ensure that you have a home that meets Standard 310. And really this is has an impact on the overall HERS score. So if you are looking to improve the energy performance of a home, Standard 310 is a carrot, not a stick. So the underlying assumption in the HERS score is that you are not doing proper HVAC commissioning, because as all the literature indicates, that is the standard. So if you are going through these 5 steps that are illustrated here on screen, which we'll go through one at a time in just a bit, the end result is that you can improve your HERS score by demonstrating that you have properly designed and commissioned your HVAC system. So now why don't we dive into each of these 3 steps one at a time. So the first step is doing a design review. So the rater will be collecting the design documentation for the dwelling that's to be rated from the mechanical designer. And that can be the contractor, it can be a third-party engineer, whoever has designed the HVAC system. The rater is going to review the design documentation and really not doing a full, separate analysis. It's really just looking at it from a completeness and comparing it to the dwelling to be rated to ensure that certain things fall into the proper parameters. So we had some debate in the committee to determine, should full manual JS&D be applied? Should there be other things, put in place? And again, the decision was the consensus we reached was let's just verify that a proper design was done, because we determined that not all raters may have the HVAC design skills to do a full analysis of was manual JS&D properly completed. But we can compare components to say if this is if this design is for this specific lot, the components within that lot, consistent with the design to help verify that, yep, we're in the ballpark for the design. And if those tolerances are met, then you can proceed on to the next task. If the design is inconsistent with the home, then you have to stop here. Then there's no ability to show that you've commissioned it correctly if the design doesn't match the house that you're evaluating. Task 2 is measuring duct leakage. So of the 4 tasks on site, this is the first of those, really measuring total duct leakage, which is something that's familiar with virtually all raters. It's following standard 380, which likely everyone on this call is very familiar with. And the results of the test, based upon whether it's done at rough-in or at final, and the number of returns that are in the system, there's different limits as to what leakage rates you can have as acceptable. If there's no testing done here at all, it's assumed to be grade 3. If it meets a certain level of performance, then that's grade 2. And if it's at a higher level of performance of duct leakage, then you can be grade 1. And again, if the tolerances aren't met here to be either grade 1 or grade 2, then you stop here and move on, and it's not you're not able to get any commissioning credits. If it's grade 1 or 2, then you're able to proceed to the next step. Step 3 in the process is measuring the blower fan airflow. There's 4 techniques that are allowed in the standard to do this. The first is looking at using a flow hood. The second is a flow grid that can be used to put into a filter slot or other mechanism to ensure you're capturing total fan airflow. The third is a pressure matching technique that uses a duct testing technique, using the same equipment used for duct leakage testing to match pressures. And the fourth is measuring static pressure and then comparing that to the OEM manufacturer's tables to evaluate what does the manufacturer say that the system's airflow will be at that static pressure level. Again, all 4 techniques are allowed based upon the experience and types of systems that you're evaluating. These different techniques may be more applicable in the region where you operate. But it's just a single measurement. It is not going around from room to room capturing all the airflows. We're trying to capture the total fan airflow, so it's generally measuring the returns or at the unit itself. And again, the process is you compare the total airflow measured to the design airflow, and if you are within certain ranges, then you're grade 1 or 2. If you're too far outside the range, then it'll be grade 3, and the same process. If it's grade 1 or 2, you proceed on, otherwise you stop here. Task 4 is now we've measured the airflow of the HVAC system. We want to measure what is the fan watt draw of that system. And then we're trying to look at how hard is the fan working to supply that amount of air. Again, there's 3 methods to do this. One is a plug-in watt meter. If you have a HVAC system that it has a plug-in, you can unplug it from the wall, plug it into this meter, and plug that into the wall to capture what is the fan watt draw. Many systems are hardwired, so that technique is not allowed or not able to be done. So a clamp-on watt meter is often can be used to measure both the voltage and current simultaneously to calculate wattage of the fan. And the third approach is turning off all systems in the house except for the HVAC blower, running that and going to the utility meter and measuring what the watt draw is, depending on if it's a digital or an analog meter. There's different techniques that are listed in the standard to do that. So one of those three techniques is used to capture the fan watt draw. Once you've done that, you can then again the standard defines what those limits that you have. Is it grade 1, 2, or 3? And then on this one, regardless of the grade, you proceed on to the next task, which is the final one in the step. So task 5 is refrigerant charge. So most of the things we've been doing now have been more inside the home. This is where we're trying to evaluate as non-invasively as possible. We're trying to determine what is the refrigerant charge of the system and how close is it. Now, HVAC contractor and the way raters work in California is doing an invasive method. So gauges are hooked up, which allows us to measure the exact pressures and temperatures of the system. In standard 310, that is not used. It's a non-invasive method only to try and minimize the risk that that there could be some contamination or loss of refrigerant, and the regulatory requirements of not anyone can use gauges. You have to have an EPA certified individual to handle refrigerant. So instead, raters are allowed to use one of two methods. One is a non-invasive method, which measures the temperatures of both the refrigerant lines as well as the airflow inside the home and the outdoor ambient conditions. And there are some tables that calculate what should the temperatures be. And if you're within a certain range, then the non-invasive method will indicate that it's close enough so that it's a refrigerant charge is in the ballpark. And the second approach is measuring the length of the line set and calculating from the manufacturer how much additional refrigerant should have been added to the system to ensure that it is properly charged. And that requires interaction with the contractor. The contractor has to do that same process, evaluate the length of the line set, measure in the charge, document that with some photo documentation, and share that with the rater to show that a certain amount of refrigerant was needed. This is how much that was added. And so that documentation is going to be sufficient. This was a compromise approach because raters in all states, this is a national standard, many states do not allow people that are not a licensed HVAC contractor to directly interact with the HVAC system, especially with refrigerant. So this compromise approach was better than nothing. We can still verify that the refrigerant charge is in the ballpark. It's not as good as doing superheater subcooling, but it is gives us close. So that's the final step in the refrigerant charge system, and this required lots of conversation in the committee to ensure that we were not getting too far off track and causing potential liability to raters. So that's it. Those are the 5 steps. So if you just take a snapshot of this page, this is really standard 310 in a nutshell. 4 years of effort and lots of documentation around it. It could be summarized in this one snapshot, but that is standard 310. So why don't we go to the next slide now? We can talk a little bit about the current status. So standard 310 is now an official ANSI standard that defines how raters are going to be evaluating HVAC systems, as we just walked through. So this is now complete. And if you want to learn more about that, the link on screen is where you can go to pull down a copy of that standard. Next is the next step in the process is, now that the standard's been approved, the development of training and evaluation so that people can be taught how to do this process properly following the requirements of the standard. This training has now been completed as well. The ResNet team has pulled that together, so that is now complete and available. So you can go onto the ResNet website and be able to access these training materials and videos to be able to have your raters complete that process and become have the necessary certifications to do the standard 310 test. The next step was updating standard 301 to accommodate the changes that are in 310 so that the HERS score calculations incorporate these changes. So that's now complete as well. The ResNet committee has completed that process. So standard 310 is now incorporated into the most recent version of standard 301. The last two steps are underway. The first of those is the companies that produce energy software. So whichever is your favorite software that you use to calculate your HERS scores, each of these vendors are underway of updating their software, most of which have indicated that they hope either by the end of this year or early next year, they will have their software updated to incorporate standard 310. And so now that can be incorporated into HERS ratings as well as for Fed tax 45L calculations as well. And the last step is the HVAC design software. So both BrightSoft and our HVAC are in the process of updating their software to automatically generate a standard 310 HVAC design report to make that process an easier mechanism for designers to provide that information over to raters. So there's going to be other mechanisms to do that, but this is going to be nice to have the HVAC, the primary HVAC design software companies providing these reports as a standard part of their reporting package. So what's the last step? What can you do today? So our recommendations are, review standard 310, get your rater training completed, and give it a whirl. Take it for a test drive. Try standard 310 out on a single house. Find out which one of the which of the testing techniques work best for the types of systems that you see in your area, and then do some arm twisting. Don't hesitate to call your rating software companies that you prefer to use and your HVAC design software vendors and say, hey, you're really looking forward to seeing those new capabilities in their software. The more they hear from their customers that this is important, then the higher up on the development cycle this will be. So let's as an industry, make noise. So let's get this out there. Okay, so why is this necessary, and why in the world? Another way to ask that is, if this is so obvious and we've known about this for 20 plus years, why aren't HVAC companies just doing this? Should this just be standard practice? Why is it necessary to do this HVAC commissioning verification? Well, my assessment is that the HVAC trade is just different from other contractors. If you become a really good framer, a really good roofer, then you stay kind of within your industry, and new construction is where the vast majority of that activity happens. Yes, there's some activity that happens in the retrofit and remodel industry, but it's the vast majority of people kind of stay in the new construction arena. As you get more talented, you get more pay, you get more seniority, and it becomes a positive thing. In the HVAC world, unfortunately, the service and replacement market is 8 to 10 times the size of the new construction market. And the margins and pay rates are dramatically higher on the service and replacement side than in new construction. So inevitably, people at a high quality level, once they usually enter the market in new construction, they kind of learn the industry a bit, they get some experience, and then the service replacement market poaches the top talent, brings them over where they have an opportunity to make more money. So it's great for the individuals, bad for us as an industry. Because your typical HVAC startup technician on a new construction project is inexperienced, typically has some limited skills. They have very little experience on the design process of how you design an HVAC system. And while they've got some instruction on the equipment, they often know very little about the duct system and airflow and how to adjust duct system. So they come out of HVAC technical school and they're put to work, and they have to learn over time. So they don't show up with this array of knowledge of how to do it correctly. And so now you have HVAC contractor owners that employ a lot of these folks, they have, turnover like worse than a McDonald's often, of trying to keep talent within their organization and knowing that they're going to be losing key people, to their compatriots in the service replacement industry. They tend to be conservative. Also, we all know new homes perform dramatically different than the existing housing stock that's out there. So they're used to going into existing homes that have crappy windows, loose envelopes, oversized HVAC equipment. And so they have to use rule of thumb to try and determine, what size should this equipment be and how to manage it. Modern energy efficient homes perform dramatically differently. So the rules of thumb that work on the service and replacement arena are just outdated for modern new construction. But often these HVAC owners, they take a conservative approach because they know if they undersize the system, they're going to be back out there with lots of service calls, and it's challenging for them. So because of that, many of these people, they don't really believe in commissioning. They don't trust the building envelope. They don't trust the skills of their technicians, because often they are more junior folks. They don't necessarily trust manual JS&D, because if they work in a lot of existing homes, it's a guess. You don't have near the precision you do in new construction. And frankly, they don't trust homeowners, because even if they get everything right, homeowners may still want to use their home differently and not use a set it and forget it approach. They'll want to run it up to 90 degrees and then want it to catch up very quickly. And so they'll get a service call even when there's nothing wrong with the system. Yet on top of that, intense cost pressure, that makes it very difficult to pay more to try and retain staff. And some contractors, frankly, they view their first service call as an opportunity to sell a maintenance plan and upgrades that builders aren't very good at selling. So they don't mind that first service call because it's really a selling opportunity. So when you put all that together, you don't get a lot of HVAC contractors that really believe in HVAC commissioning and drive it. So that really is one of the reasons why Standard 310 is so necessary, because of the unique industry dynamics that new construction HVAC contractors face. They're not in a place to naturally adopt this. Many have. There's some great contractors out there that do this on every one of their installs, and those are the ones that are going to be in high demand as Standard 310 really starts to take hold in the industry. So what does this mean for raters? Because of the labor situation, and even with COVID and the impact that's had on the overall national workforce, we all know that the construction workforce is still very slim. There's not a lot of talented, skilled people that are readily available to fill many of the construction construction jobs that are out there, especially in HVAC. So the rating industry has an opportunity of, we don't have that same dynamic of a significant amount of turnover in our workforce. I'm sure as rater owners, we all feel that it is challenging to attract and retain talent, but we don't have near the turnover that many of the construction trades have. Thus, we can help further train our staff to help the HVAC industry that has had that greater turnover to deliver a greater overall quality outcome for homeowners and for builders. And if we do that well, and we do that consistently, the benefits are great for both builders, contractors, and homeowners. It's obvious. There's going to be fewer warranty calls. That helps everyone. Improved comfort, lower utility bills, a lower HERS score, which is one of the key things that Standard 310 now delivers. Also tied in is you get improved 45L tax credit qualification. That's been a little bit of uncertainty around that issue, and that has now been cleaned up with Standard 310, which is a big benefit to the industry. And for the contractor, you now have a third-party independent assessment that your system's in a known good state when it was delivered to the homeowner. So now when you go back out there on a service call, you have a independent documentation of, hey, here's how the system was performing on this date, and now something has changed. It allows the contractor to more readily find out what's the underlying issue, and really avoid them being stuck servicing issues that were not of their cause. So it's a great way for the rater and the contractor to partner up to help in delivering a better result and avoid warranty service calls. So that is the formal part of the presentation. Pause now and happy to answer questions.
Thank you, Greg. And again, apologies for some of the technical difficulties we had at the beginning of the call, but it was some great content. Let's see, going back, there were some questions about what about VFV systems or systems with ECM motors that are constantly adjusting? Does that factor into this at all?
Yeah, so the ECM motors versus split capacitor motors, they will perform differently based upon the static pressure, of course, that the system has. So instead of as the static pressure increases and the airflow decreases, those more advanced motors will rev up their energy consumption to ensure that the target airflow is achieved. So this standard will capture that. That's why we measure both the total airflow as well as the fan watt draw, because the goal is to find, do we have systems that are operating at the proper static pressure? If they're not, you're going to see one of two things. You're going to see reduced airflow, or you're going to see excessive energy consumption if there are restrictions in the system and you have excessive static pressure. So the standard was designed to capture that issue regardless of what type of motor is in the system.
Okay, great. Another question is whether a rater who holds the proper EPA certification can use the invasive method, or is it prohibited?
So for the standard, this was heavily debated, and because it's included both ACA and ResNet members, the decision was, even though it's best practice as an HVAC contractor to use the invasive method, the standard does not allow that process. So unfortunately, there were advocates on both sides of that, but the decision was to not allow the invasive method because that could create potential liability for the rater, and the decision was to not include that. So if you're using standard 310, the only two methods allowed are the weigh-in method and the non-invasive method.
Okay. There's a question about optional testing. So if I understood correctly, the person asked, this is optional testing to improve her scores. However, is it mandatory for Energy Star Revision 10 report?
So this is an optional test for ResNet purposes. It's not mandatory, but it is. I think it'll be very popular because it'll be one of the lowest cost ways of pretty dramatically improving her scores. And just on that point, some of the data that has been evaluated in this system, that for more mild climates, if it's air conditioning only, you may see 1 to 2 Hertz point improvement. In more in climates where there is a heavier use of HVAC systems where it's hot and dry or hot and humid, then you may see as many as 4 or 5 Hertz point improvement by doing HVAC commissioning. Or if you're using heat pump equipment in most any market, you may see that same level of 4 or 5, as many as 6 points improvement, just because the both season impact. So sorry, I got off track on the question again. I wanted to hit that point first.
Sure. Should we go to the next question?
No, I just wanted to make sure I fully addressed that question. I just forgot the original question.
Sure. Asking whether or not it was mandatory for Energy Star Revision 10 reports.
Yes. So Energy Star, as far as I know it, they have switched to allowing standard 310 as one method of meeting the HVAC component of the Energy Star checklist. So there's the traditional approach that can be done, as well as standard 310. So it's not required, but it is an option for now. But I would visit the Energy Star website to get details. But my understanding is it's one of 2 options.
Next question: how long in your experience does it take to do these tests outside of the total leakage test?
So we had during the standard development process, we had a number of different raters perform this testing with minimal training. They had some familiarity with this type of testing in the past, and so we captured the time that it took them to do this. And the testing varied from at the low end 15 to 20 minutes to the higher end of kind of 35 to 45 minutes was the impact on timing. With again, very little training and doing it just for the first time. So the expectation is that with experience and process improvement for your typical house, we should see kind of per system that to be in that kind of 10, 15, 20-minute range is where I think we should expect it.
Okay. Someone asked if you can comment further on the reasoning and step 4 for passing any system regardless of fan watt draw.
So it's the fan watt draw. The reason you're allowed to go forward on that, even if you're at a grade 3 on that approach, is that it doesn't have a prerequisite like some of the others do. If you have significant duct leakage, or if you don't have the proper airflow, then that really eliminates your ability to do some of the additional tests. If you don't have the right airflow, then it's really hard to gauge whether you have the right refrigerant charge. Similarly, if you have excessive duct leakage, then that's going to have a significant impact. So those are kind of prerequisites. You can have excessive fan watt draw, but still have a system that may meet a grade 2 level. So based upon the data that you enter into the system, the software will calculate those and help you determine that you may not get the full HERS point score improvement, but you may still get some point improvement if you do have a demonstration that the other elements are grade 1 or 2.
Okay. Next question. What's the rough cost of buying the non-380 test equipment? Flow meters, watt meters, temperature sensors?
It varies dramatically based upon which equipment you select and whether you do kind of standard equipment or if you do the more advanced equipment that has some of the Bluetooth and or Wi-Fi connectivity. So I would be speculating on each of the different piece of equipment, and it may vary from region to region. So don't wish to comment on that because I could be way off based upon pricing in different areas.
Sure. We have a question about going back to step 2 of the process. So if ducts don't meet the grade 1 or 2 target, then what happens? Can you get grade 3 for airflow and refrigerant charge without measuring, or do you each get separately measured?
No, that's one that's if you don't pass a grade 1 or 2 of your duct leakage testing, it's a stop at that point. So if you have excessive duct leakage, you're not able to get either a grade 2 or a grade 1 for any of the other tests. So if you're at a grade 3 with duct leakage, it's a stop, and you're a grade 3, you're not able to get any credits.
Okay. We have a lot of questions. Using a clamp meter, what is the safest and accurate way to feature voltage with the electrodes?
Yeah, so the clamp on watt meter, that is one of the key elements of that, because you're going to be around live wires. It's required to be done at the HVAC equipment. It's not allowed to be done at the panel, at the main electrical panel. And it's again, I won't get into a ton of details here because it varies a lot based upon the equipment's accessibility and is it upflow or horizontal or things of that nature. But it's generally you'll find the proper leads on the system to clamp onto to both measure voltage and current. And again, the key is to do that safely. So my recommendation is to watch the videos that have been produced by ResNet on that process. And there's a rather extensive discussion around safety, because we want to make sure that anyone that's doing that testing does it in a very safe manner.
Okay. For the blower fan watt draw, can you describe the amp clamp procedure for a hardwired unit? We know we must isolate the hot wire, which seems like we must do this with the air handler cabinet door open. And we have heard there's a safety feature that kills the blower fan at the door of the jar.
Correct. So the answer is that's right. You do need to generally access the blower compartment when you're doing this. Often it's a piece of tape used to cover up the kill switch that is used, so you can both access the the blower cabinet and have the blower operating. So so that is, you know, one of the challenges is doing that both in a safe manner and ensuring that you able to find that kill switch and be able to make it operate correctly.
Okay. What do you see as the big differences in alignment with what is already in the IECC that theoretically already requires manual J and some testing?
So this is this standard 310 is kind of a reflection of reality. ACA manual JS&D is already ANSI standards as well. It's in the IECC. So this is aligned with that. It's a reflection of the reality that even though those standards are in place, no one is really verifying that. Your typical code inspector is not verifying refrigerant charge. They're not measuring airflows. They're not ensuring that those steps are being done correctly. So Standard 310 was created as a mechanism of encouraging both contractors and builders to do this. They're really bribing builders with HERS points to do this activity. So if we are going to provide additional HERS points for properly commissioned systems, that was the decision of the committee to create Standard 310. So it is consistent with those other standards, but what it's trying to do is create an incentive so that people actually follow them.
Okay, and I think this might be one of our last ones. Is there an option to do this testing before HVAC startup?
So some of the testing can be done before HVAC startup. So the duct leakage testing, for example, that can be done at the rough-in stage versus at the final stage. But most of the testing, so the fan watt draw, the refrigerant charge, things of that nature, inherently cannot be performed until HVAC startup because you need the thermostats in place, you need the refrigerant charge released and power on into the whole home. So a subset of the testing can be done before startup, but not all of them.
Okay. Question about the kill switch you mentioned earlier. With circumventing the kill switch and having the fan cabinet access panel open, change both the static pressure and fan flow for an ECM motor, change the watt draw.
Yeah, so it's going to require you to, put the device on the system and then reclose the cabinet to ensure that you can, capture the reading correctly. So it's going to be, it's not an easy test to be done, but yeah, it's because you're trying to measure fan watt draw at standard conditions, you are going to need to reclose that cabinet door to capture the measurement.
Okay. There's a question about ductless systems and I guess how they play into the standard.
Yeah, so ductless systems, portions of the standard don't apply. For example, a refrigerant charge does not come into play with a ductless system because they have an electronic metering method. And of course, duct leakage, if it's ductless, doesn't come into play. Details of how ductless systems apply are in the standard. But yeah, many of the tests do not apply because they're not relevant. So makes it easier to get a grade 1.
Okay. For a final total leakage test with less than 3 returns, can you have up to 8% duct leakage and get a grade 1 assessment? Why aren't these values tighter for grade 1?
So the whole idea is to encourage tighter duct systems because the more duct leakage we have, the less efficient the system is because we're delivering conditioned air into spaces that are where it's not intended. So the reason grade 1 requirements are tighter is to allow a grade A set. So it's not a pass-fail, it's a grading system. So grade 3 is it's not tested at all or it's above the limits. Grade 2 is you have good duct leakage, but not great. And grade 1 is you're at a very good levels of duct leakage. So that was the intention of the standard was to encourage contractors to design to build and install systems that have lesser and lesser duct leakage.
Okay. All right. Are there different standards for ducts within the thermal envelope?
So the duct leakage analysis, is looking at both. We always have to consider both total duct leakage and leakage to outside. And it's been a bit since I've looked at that portion of which how that applies. But yeah, I'd have to revisit the standard. It's been a while since I've looked at it because I remember we went round and round on that issue, and I'm just trying to recall exactly where that landed.
Okay. All right. You mentioned videos on testing methods. Where can we find those videos? Were you speaking to the ones done by Dean Gamble and others?
Yes. Yep. Those should be on the ResNet website, I believe.
Okay, and I think also on the Energy Star pages as well.
Correct. Yeah.
Are there any?
Yeah, just
Go
to
ahead.
follow up on that, yeah, Dean has done a number of presentations that go into considerable more detail on the actual testing process. So if you want to visit the Energy Star website, I know he's done presentations previously at the ResNet conference and recently at the EBA Summit. He and I gave a presentation on that, and he does a very good job of going through each one of the testing methods in more detail. So that would be my recommendation if you'd like to see further details of how each test is performed.
Okay. We have a few more minutes left so far. That was the last of the questions. So if there are any final questions, please type them into the questions feature, and we can ask those of Greg before our time is over. Let's see. Okay. Any other final comments you'd like to make, Greg, about any of this and sort of the future with this standard change?
I think this really is an opportunity for the rating industry to have a big impact on a variety of elements of the construction process. So by approving the warranty calls, you'll be a friend of the builder, a friend of the HVAC contractor. No one likes someone looking over their shoulder. But I think as you build closer relationships with your HVAC contractors, they will come around to realizing that this is a good thing for them. It's not a bad thing. I think this will tend to have builders contracting with higher quality HVAC designers and contractors. So I think that will help eliminate some of the issues. So those that know how to do it correctly, I think are going to get more business. That will make our jobs as raters easier. So I think this is a really good thing for the industry. And as we all know, there's always pushback on new homes with smaller HVAC systems, and there often are views that people are getting something less. But properly commissioned, well-designed and installed HVAC systems that are sized at the levels that manual JS&D recommend, they do perform, and they perform well, and homeowners have a much lower utility bill as a result, in addition to being comfortable. So I think this is a great opportunity for the rating industry.